Good day to all. Today we are going to see about that selection of motor for particular applications. How we can select that motor for some applications. See, economical operations can work continuously and take the places of two or more laborers. The dependable it is always too ready to work, but the efficiency ranges should be at least it will be 65 to 95 percentage. We need most of the times the maximum efficiency range. Here it's noted to 65 to 95. Then long life, it is 20 to 30 years with the proper care. The ease of operation is it should have some special skills not required, but it is safe if it's probably used for that particular motor. That are the main applications, and according to that low service requirement, the minimum amount of attention required for the services. Then quiet operation when properly applied and installed. Automation which is can be automatically and remotely controlled. Because if we are be somewhere, so we have to activate a remote wise that particular motor. Then the adaptable which is light, compact as well as easy to move, available throughout the country. It should be available, and the bases should be standard, and the size is also which comfortable, and wiring equipment, etc. This is the rectified control of DC series motor. Here it's a AC supply, and we'll have there is a T1 and a T2. Here it's a diode D1 and D2. This inductance, reactance, and the EMF. If we are giving to the power supply to this circuit, then this will act as a T1 and D1. See, the current will flow which T1 to here, then here, then it will come over here, then it will go here. Now it will act as a positive energy to this circuit. Then the inductions will have a storage on the time. If it is no power from the input side, that time this inductor will have the circulate the current over here. This is the main concept of a rectifier control series motor. The formula for that rectifier is Vm sin omega t, which is equal to RAIA omega plus LADIA by dt plus F into IAM d omega m, which is alpha is less than or equal to omega less than or equal to pi, which is equal to RAIA plus LADIA by dt plus FIM omega IM. For that, pi less than or equal to WT less than or equal to alpha plus 5. Here EA equal to KA omega M and KA equal to F into LA, VA equal to EA plus IARA, omega M equal to VA minus IARA divided by KA, where T equal to KA into LA. Now we will going to see about the supply harmonics power factor and the ripples in that motor current. First one is rectified fed DC drives have the following drawbacks. The distortions of apply. The source current of rectifier has harmonics in a weak AC source. With the high impedance current harmonics distorts source voltage. Then the low power factor. If we are assuming a sinusoidal supply voltage, a power factor of rectifier can be defined as PF equal to, PF is nothing but the power factor is equal to real power divided by apparent power. The real power formula as we know already, VI cos pi 1 divided by Vm. Therefore, I1 divided by IRMS into cos pi. That's the power factor, low power factor. Then mu is called distortion factor and cos pi 1 is the displacement factor. Now ripple in the motor current, we will see the rectifier output voltage is not a perfect DC, but consists of some harmonics in that addition of DC component. Therefore, the motor recurrent value of also has an harmonics in addition to the DC component. So it has a addition of DC component over here. Then the presence of harmonics makes RMS value peak values of motor and current either then higher than the average value. That is the ripple current in that harmonics motor. Then the self-controlled synchronous motor drive employing load commutator thyristor inverter. So you can see the medium power also employ the permanent one. Then the magnet synchronous motor, which is source side converter, is a 6 pulse line converter, which is a commutator converter. For firing angle, the range is 0 to 90 degree. Works in a line commutated fully controlled rectifier, which is delivering the positive VDS and the positive ID, which means ID means current over there. And for the range of the firing angle is 90 less than or equal to alpha S and less than or equal to 180. See, for positive current, this positive current will have a range of 90 to 180. If it is line commutator controlled, it has a 0 to 90 degree. This is a commutator delivering a negative and a positive ID. If it is negative, then the angle is 0 to 90 degree. If it is positive, then the angle is 90 to 180 degree. Now we will seeing the synchronous motor drives. See, this the synchronous motor drive. We have a AC source, and this is the rectifier, and this is the inverter circuit over here. This will go for the synchronous machine, and it will connected with the trigger circuit. Then this trigger circuit have an input of current control over here, and this will connected to in between these two rectifiers as well as the inverter. The main thing is this is the source side, this one is the source side, and this one is the load side. If it is the angle is 0 to 90 degree, then it will act as a rectifier. If it is 90 to 180 degree angle, it will act as a inverter. Likewise, same here it is 0 to 90 degree, it will act as a inverter. And if it is 90 to 180 degree, it will act as a rectifier. We'll see here. See, for self-controlled synchronous motor, a motor drive employing a load commutator thyristor inverter in the above figure, we'll see. And see, in large power drives, wound field synchronous motors is used here. The medium of a power drive also employ a permanent magnet synchronous motor. Here you can see this is the permanent magnet synchronous motor over here. This is the permanent magnet synchronous motor. Then the drive employs two converters. As I said before, here there are two converters which are termed here as a source side converter and load side converter. You can see here, this is the source side converter. This one is the source side converter and this one is a load side converter. So the source side converters has a 6 pulse line commutator thyristor converter, as well as same in load cell also have a 6 converters. For the firing angle, the alpha S If it is 0 to 90 degree, it works as a line commutator fully controlled rectifier, delivering a positive VDS and a positive ID. You can see over here, if it is rectifier, the angle is 0 to 90 degree, it will give a positive VDS as well as positive current over here. Likewise, if it is 90 to 180 degree, for the range of firing angle 90 degree to 180 degree alpha S, it works as a light commutator inverter, delivering the negative VDS and positive VDS. See, if it is 90 to 180, here it is 90 to 180 means it will deliver a negative ones. Vice versa, the process will takes here also. If it is 0 to 90 degree, it acts as an inverter, and 90 to degree as a rectifier. According to that, we will have a positive current or positive voltage. Here, the same process will take place. These are all about the synchronous motor drives. Thank you.